everyone. It's great to see so much international representation today. It's a lot of fun. So I'd like to introduce Mark Ginsberg. He is a native New Yorker and is a partner of Curtis Ginsberg Architects, has over 33 years of professional experience in planning, urban design, institutional, and housing projects, which is where I've seen him the most. His expertise in affordable and mixed income housing, resilience, and green design has been recognized through his many lectures at national and local conferences and meetings. And Mark has really led Curtis Ginsberg Architects' efforts related to developments and sustainability. And that includes more than 10,000 units of housing, most of which are affordable and sustainable. So thank you, Mark, for joining us today.
Thank you. And let me put up my presentation. Hopefully people can see this. And anyway, so I'm going to talk about two projects that recently won NYSERDA's Award of Excellence for round 3. And what NYSERDA has been doing is that this is the third round. They have been awarding projects that are exemplary in sustainability, recognition, and some money. And it has been really helpful because many of our clients are interested, but most of what we do in both projects I'm going to show today are affordable housing, and money is very tight. And so any help is appreciated, and it also encourages them to allow us to stretch the envelope. So let me talk about the two projects. I'm also going to talk about a few issues that we are looking at with the projects and don't have full answers for. Whoops, so anyway, Castle 3 is for the Fortune Society, who deals with people in and coming out of incarceration, and housing is a big issue. So this is going to be supportive housing. I'll talk more about it. For those who know New York, it's on 123rd Street between Park and Lex, right near the elevated Metro North line, and the lower right is a rendering from the elevated Metro North 125th Street station. So the building is all electric except for code required emergency generator. We've been designing it to passive house standards. You also can see in this diagram, and I'll talk a little more, we were trying to maximize space. So our cellar both goes under the setback at the front and at the rear yard to give more space for Fortune's operations. The other thing is, because of the zoning, we were able to put a full trellis of PV at the top roof, and I'll talk more about the front wall, which we're looking at. We're following enterprise green communities, have to actually, but very tight envelope, ERVs, all the sort of standard stuff to make a green, low energy, operational carbon, but also we've been looking as much as we can in embodied carbon, and I'll talk about that a little later. These are just some detailed studies. So the front south-facing facade, we have these metal panel sort of fins around two windows, and we did studies to try and maximize the shading in the summer and minimize it in the winter. The section here at a window is just showing how we're designing to minimize any condensation and make sure we had continuous insulation. And on the right is a parapet, and we've learned a trick to not having to insulate fully at a parapet. I don't know if you can see the mouse here, but what we do is the first width of concrete block above the slab is an aerated concrete block, which has an R value of about 12. And that, as you can see here, means that we don't need to insulate above on the parapet because we've dealt with the thermal break with the aerated concrete block. Uh, these are just some floor plans. So as you can see in the cellar on the left, we have all our utility space, but all the yellow area are offices, etc., for Fortune. And we have a number of skylights from the garden above. And then on the first floor, besides the lobby, we have some more public space with a teaching kitchen and meeting room that Fortune will use, but also will allow the community to use. And then we have a rear recreation space, and zoning required the setback. So we have a, a landscaped front terrace with trees. And then the building goes up fairly standard double loaded corridor with a large number of studios and then some ones and twos. And anyway, this is the front elevation. But what I want to talk about is up here. 3 years ago, when we started this project, we had to go through rezoning. We're supposed to break ground in September now. We said, well, why don't we put PV on the facade as a rain screen and generate electricity, but also save money by having the PV also the rain screen? And the problem was there was nothing made at that point. So we're now looking, so that got cut, but we're now looking at, there are two companies, but we're looking at Mitrex, who makes a solar rain screen, and you can print colors or whatever on the front, although the darker it is, the higher performance. So we're looking to potentially add to the rooftop trellis generation by the rain screen on the wall. And for those of you in the US, the Inflation Reduction Act helps us on this, because there is at least 30, and it could go up to 60% tax credits or for not-for-profit funding. We will also ask by NYSERDA to look at this issue, which is we're cooling the building. So we've got condensers on the roof that are sending out heat. And then we're heating hot water where we have a condenser or condensers on the roof that are pushing out cold. So the question is there a way to take the heat from the cooling to make the heating of the hot water more efficient? And sadly, although you can find things like this for single family houses, we have not found any system for the multifamily house. And our client is very conscious of operations, etc. So we're still looking, but it's looking like, although this clearly is a low-hanging fruit, someone needs to make the equipment to make it easy to do and maintain. I'm now going to talk about Shore Hills, which is senior housing on a site with existing senior housing out. For those of you who know New York, we're a block from the harbor and near the Verrazano Narrows Bridge in a very mixed scale neighborhood, which in terms of the design was something we thought a lot about. So to understand, the West Building and East Building and Community Center are existing. And this whole eastern part of the site was basically a parking lot. And so we are going through getting a variance to reduce parking and also some other stuff. And hopefully we'll be closing on this in about a year. But we're creating about 150 units of new senior housing on existing property. And the parking was underutilized. The other thing we're doing, I'll talk a little more about this, is the landscape for the existing development is being upgraded. And we're at least looking at potentially at electrifying the existing buildings. That's something we've been studying with our client. So anyway, just a diagram. This project is Passive House. We're also doing Enterprise Green Communities and Well. Again, ERVs, very airtight envelope. We're putting up some photovoltaics. We're looking at using a wastewater, hot water system. For those who don't know, it's a system where you put a tank in the cellar and you use the water that's coming down, which is around 60 degrees, to extract the heat for your hot water heat pump. So because it makes it much more efficient than when it's 30 degrees out. And again, just talking about design features, in addition to the new building, adding bioswales, although we're well above the flood line, there's local sewers have real issues and heavy rainfalls, and we're trying to cut the load on that. Creating recreation space for the residents, since many of them can't go that far. And then our new building trying to deal with this varied context. On the left is the ground floor plan, where we have our lobby, a series of community amenity spaces and support spaces. And also we tucked some parking under the building, because although we were reducing parking, we needed a certain number of spaces, largely for the existing building. And these senior buildings, although the seniors tend not to own cars, many of the people who operate and support the building do. And then when visitors come, they often drive, even if we would prefer them to take mass transit. And I'm going to end. We have gotten an early design funding from NYSERDA, and we were doing a very deep dive into embodied carbon on this building. And what we're finding, and I don't think this will be a surprise to anyone, that concrete plank, concrete block, which is unit masonry, is 80% of the building's embodied carbon. And then we've got metals and finishes and insulation. We've looked at a number of software to do a full analysis. That has been interesting, because it's changing by the week. It's hard to get EPDs. They're often not available. And one of the interesting things, so for example, with concrete plank, because this is a block and plank building, there is a company out on the West Coast that makes concrete plank with carbon cure, but none of the 5 local manufacturers make it, and we're trying to encourage them. And then, as I said, we're looking at metal. One of the interesting things, since most of the, at least steel, but most of the metal is recycled, we're looking potentially to get our steel from Quebec, since they're all on hydropower, and the arc furnaces, if it's powered by hydropower, does not use fossil fuels. We're also looking at insulation and windows and storefronts. And with that, I'm going to finish. I look forward to answering questions. And I'd also add that Brian Toos, who's a senior associate and the project manager for Shore Hills, and who has been doing the deep dive into the embodied carbon at Shore Hills, is here to answer questions that I can't. And with that, I look forward to answering questions that people have.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Thanks, Mark. The first question we have is from Ashima. So she had a couple questions. So we'll start with there, and then I'll line up a few more.
Hi there. Thank you for that great presentation. My question was if either of the buildings had large storefront areas, and if so, were they required to be triple pane?
Well, and Brian may know this for Shore Hill. They have on the ground floor some storefront area. What we've often found with larger passive houses is that as your building grows and your volume goes up in a cube and your surface area goes up in a square, I think that's correct. And so the extra U value or R value, or however you want to, of triple pane, we often haven't had to do in passive house buildings because the buildings are 150,000 square feet, and the surface area is just less than the volume. And, we model on each of them. So, Brian, do you know if we need to do triple pane on the storefronts at Shore Hill?
We're not there yet, but
Right.
I know that from another similar size building, the beach green yeah, anyways, recently we did one without triple glazing. It was around the same size.
Right.
All right, good stuff. We're gonna head over to Melvin. I know our good friend Peter talked about bike racks. He's joking about lead qualifications. So, Mr. Molnar, we appreciate your humor. We'll skip over to Melvin.
Well, let me just answer one thing on
Okay.
bike racks. New York City requires that for every 2 apartments, you have 1 indoor bike rack. And so all our buildings typically have a bike room with bike racks. Senior housing is somewhat less. One of the issues we're dealing with, which I haven't found a good answer for, is electric bikes, which are all over the place. And there have been a number of fires because the battery, if you get a cheap electric bike, the batteries often aren't very good and sometimes burst into flames. But
Yeah,
so we do have bike storage.
I appreciate that, Mark. That's good info. All right, Melvin, over to you.
Thanks a lot. Yeah, I was wondering about the air barrier strategy for the Fortune Castle 3 project, particularly in this cellar with utility spaces. Because I know like the trash room, they can have very high exhaust rates, and typically these spaces we want to keep out of the passive enclosure.
Well, it's interesting. We've done buildings where we have commercial space where we can't fully control it. So the envelope is passive house, but we don't know the mechanical system. And so it's out. We're using ERVs, so where we have to ventilate like in a trash room, we're using it to temper the incoming air. But in terms of air vapor barriers, I'd have to check, but we typically, we'll have a vapor barrier outside the concrete wall, inside of the insulation.
I would say also, Mark, I think that when we do the trash rooms and I think we do put an air barrier. It sort of goes up on the inside of the chute, right? So it sort of isolates it from other parts of the building envelope. I'm pretty sure that's what we did on the recent one.
And so just a side question, is this FIAS or PHI?
Sure. Well, Fortune, I'm sorry to say this, so far the client hasn't agreed to get it certified. So we've designed it to passive house standards, but we're not certifying it. Shore Hills will be certified, and I'm not sure if we've picked that yet, but it may well be PHI because we have lots of small units, and that is often more difficult to do with FIAS.
All right, thanks.
Great. Thanks, Melvin. And Peter from Small Planet had some mechanical stuff. So Peter, over to you.
Hi, thanks. Hi, Mark.
Hi.
Sorry for posting it twice, but I was wondering if the mechanical engineer didn't look at heat recovery chillers to deal with this issue that you mentioned about heat being injected from the building and heat
Right.
being drawn to heat domestic hot water. There's several nice manufacturers on the market. They do this.
Right.
Not a,
They're looking through that, and thank you for the suggestion. I would add that something interesting, you know, we've used mini splits, and for example, on Fortune Castle 3, we've also used ground source heat pumps where it makes sense is great. But we've also been looking at these unit mounted systems. A number of companies are now making them, which is a heat pump that just gets mounted in the room. It's a modern, in effect, PTAC. And the thing that appeals to us about that is you're not running hundreds of feet of piping with coolant in it, which is done on site and which will leak and which is a horrible greenhouse gas. So getting a system where you need less coolant because and all the piping is done in a factory should reduce that, and has some other advantages too if you can get it tight enough to meet the blower door tests.
yeah, I hope they can figure something out with heat recovery chillers because they're fully hydronic. It's all just water. You know, it's not that new. And it wouldn't be possible with these PTAC type things because then you eliminate the
Exactly.
So anyway, back to you.
No,
Thanks.
great points. Thanks, Peter. And Perik had a comment. So Perik, over to you.
I think you're on mute, Perik.
Thanks, Bev.
Sorry, Bev. Sorry, guys. Sorry, Mark. You mentioned BIPV Matrix, and you're doing a section in the building. Do you have a strategy for how much of a building you would want to use, or is it a cost issue, or you know?
The big issue is where you've got enough direct sunlight.
Right.
And we're doing this upper part because in the lower part, there are a number of 10-story buildings around it. So the lower part will not get as much direct sunlight. But since the building is 15 stories, the top 4 or 5 floors where we have that setback, and we also have the setback wheel, we're looking at using it on some other locations too. We haven't used it yet because it's a relatively new project, and getting through the construction timeline design and construction takes years. But we think it has a lot of potential, and I think there's now also another manufacturer making something similar.
Yeah, I think there's more coming out. Yeah, I did a tour of Matrix recently. It's a very interesting facility. So yeah, good for you.
Well, one of the things that New York City and any other dense urban environment has a much lower per capita carbon footprint when you correct for cost. However, once you go up above 3 stories, you can't generate enough electricity with PV to power your whole building. And so this is really appealing where you can do it, where you can power more of the building. The other issue, which is New York has a very conservative fire department with reasons, so it's very hard to put batteries in a building. And I'm hoping over the next few years, people come out with batteries that won't burst into flames, so we could put them in the buildings to make the buildings both more resilient and also use more of the electricity on site.
Yeah, actually interesting. There's some research being done on sea salt technology batteries, but it's still early stage, but it's promising. But anyway, yeah, right. It's all good. Yeah.
No, great stuff. Great points. Andrea, you're next. And just check your comment here, Andrea. Maybe Andrea, yours was more of a comment than that. Bev, we'll go to you. You got a bunch of questions and comments. So
yeah, so Mark, it's so great to see you're interested in embodied carbon. I think that's like one of our biggest challenges these days is making sure that we're being consistent with that while we're doing these really high performance buildings. You're interested in concrete. So in Massachusetts, we also are having trouble getting EPDs for different mixes, but I will say it's super cheap for them to get up and started. And so like we're doing a small grant program, MassDEC, for all the 63 ready mix companies in the state so that they can do instant EPDs. I mean, there's really like 30 or so things they might put in. So it is not that hard for them to get set up and third-party verified to do instant to anyone. Precast is tougher, but I would definitely start with the National Ready Mix Association. They're very interested in this and get you to the right people if that's what you're looking for.
I've done some work with them and they are very helpful. I'd also add, I've heard about how Seattle in their building or energy code is going to put embodied carbon limits on concrete depending on the PSI. But one of the interesting things is it depends on how clean your grid is. So in the Pacific Northwest, where you have a lot of hydro, it's a cleaner grid than in the Northeast right now. But that is hopefully changing. And I think there are ways to fairly easily start to control and encourage low embodied carbon concrete.
Yeah, have you heard of Positive in the New York City area? Because that's a glass pozzolan that a lot of
yes,
people are
well,
using.
there are two concrete block manufacturers we're looking at. One in Brooklyn uses carbon core cure. The other in Kingston, New York, which is under 100 miles, uses the Positive. I'm not pronouncing it well, but
Yeah.
And so we are looking at that because that clearly will help.
But you can do both. And honestly,
Right.
glass pozzolan's as cheap as fly ash. So it's actually cheaper
Right.
than Portland. So it should be cheaper, right? So
And fly ash is interesting because it's good to use, but given that we're getting rid of coal plants, it's going to disappear.
and same with slag. But
Right.
concrete ready mix folks at least are very used to using that. Like most mixes you probably ask for have a decent amount in them because at least sometimes fly ash and slag have been cheaper. So it's probably common for you, any mix you ask for has 20% in it. And so like switching over, getting them more comfortable with the ground glass pozzolans. And actually I like the glass pozzolans because they're actually more resistant to salt at street level. So like your sidewalk type applications and first floor applications might be more resilient over time. But there's a lot of new things coming in that mix kind of thing. So that's, you got to keep at the block manufacturers to keep, asking for it and more people asking.
And I think this is a really important thing. If we all keep asking them for it, like the plank manufacturers, we said, well, you can do carbon cure. It's already being done on the West Coast. That if enough people ask, one hopes they will start to realize that, hey, this is a market advantage if we can do it.
Yeah, I mean, if there's no other message to all of you who are using concrete, it's ask for an EPD for everything. And they may say, I don't have it yet, but like the more people that ask, the more likely they'll take the EPA money to start doing EPDs.
Sorry, I wasn't able to jump in earlier. I just got my audio fixed, technology woes. Just to add what Bev was saying there, one very interesting thing about fly ash, I mean, we're actually hearing in Canada, where I'm talking to you all from, the concrete specifications that govern the building code in Canada now allow for fly ash to be taken out of landfill. And we know there's a lot of fly ash underground around North America and treated as a manufactured product. It's treated and then can be used in concrete with all appropriate quality screenings. So the nice thing in terms of lowering carbon there, there's no additional coal burning going involved. Lots of great benefits to lowering carbon in concrete through use of that. So hopefully the great minds in concrete and writing the specs down in the US are watching what's happening in Canada in that regard and getting that integrated so that can be leveraged, since, as we know, traditional fly ash is going away. And then the only other thing I'd share from that's quite a success story specific to concrete block in Ontario is a technology called Carboclave. There's now probably 6 to 8 different plants, a very large concrete masonry plants across Ontario that are using the carboclave technology rather than going with carbon cure because of they're achieving much lower carbon results through their independently verified EPDs. So it's just something that's showing up in a lot of specifications up here and being very quickly adopted by all the concrete masonry producers in the province of Ontario.
Yeah, Andrea, really good points. And I mean, it's just exciting to see what's happening in the embodied carbon conversation. I mean, I just think that the whole Carbon Leadership Forum, what they've done in 5 years and the bandwagon we've all got on about understanding our footprints, our carbon footprints and concrete being the most. And Mark, I'll just jump in quickly before we ask a couple questions is in that the embodied calculations, where did solar panels lie? Because I know that solar panels are getting as high as some other materials. So when you're looking at, it's typically like carbon, steel, and solar panels that I'm seeing when we're looking at it. Did you guys include the solar panels in that calculation of I think you did it at Fortune.
Right. No, we did it at Shore Hills. Brian, can you?
No, solar panels wasn't part of that.
Yeah,
just it's not actually. I mean, it'd be interesting to try the software that we're using, which is tied into. That's one of the things we're looking at here is how can we use the models that we make to actually test this stuff out. That's not part of the sort of the category inside of Revit that gets spat out into these things. So definitely, I would like to look in that though.
I just like to interject. I think it also raises kind of a philosophical question about whether solar panels really should be counted as part of the building or as part of our energy system. Because when you look at the embodied carbon or the upfront carbon of a solar panel compared to the life of the energy production from that solar panel, and you do the math, it's incredibly low carbon energy, right? And so we all know that we need to move to low carbon energy. And sure, there's going to be some upfront cost to that in terms of carbon, but that is, that's offset like within the first year. So I think it's a little bit, I feel like it's kind of a red herring when we're looking at embodied carbon in buildings, and the other dynamic that's going on is that the carbon intensity of the panels is rapidly decreasing as well. So just to put that out there, I think maybe it's okay that Revit doesn't see solar panels as part of the building itself. Not to say it's not an interesting question, but we need this energy transition to happen, which means more panels.
No, Zach, I love that point. And the reason that I brought up again is just the fact of when we're building buildings, if we're trying to get to zero carbon and we only think that we can build code-built buildings and then add a whole bunch of solar panels, that's not the right approach. So we need to make sure that we're doing passive house and making sure
Absolutely.
we're doing our principles. And then at the, when we've got this really excellent envelope first approach to our buildings, and we've looked at the embodied carbon and we've electrified, then we can throw the solar panels on. But again, I love how we've got pioneers out there. Like I got to give shout out to Tim McDonald for creating this whole solar panel tower. And now we're seeing solar panels being on facades is just, I mean, again, if you're not ready for it, it's coming. And I think it's sexy. I think it looks great. And the fact that, Mark, you've done it here and you're looking at intentions with rain screen details and trying to make it look and feel like the facade. It's just great that you're trying to be creative. So
I would add in another one, we're looking at making it into artwork because you can print, each panel can be different and you can print stuff on it. So the only issue is the darker, the better in terms of production. But if you're doing a design, you may have to balance that with the design.
Well, I'm kind of going back to Zach and Solar Punk. Or go ahead, Mr. Solar Punk. I just wanted to. That's super cool, Mark. And I also wanted to just
emphasize, Sean, how important the point you just made is about, the efficiency and bringing down the overall energy use, so that we don't have to just have solar panels, more solar panels than we need. And that's true both on the building scale when you're trying to hit net zero, but it's also really importantly on the overall grid scale and the societal scale. So the more that we are able to make high performance buildings, low energy load buildings, that means that we won't have to overbuild to deal with the winter heat load and all that. So there are parallels at both this building scale and the wider one.
I would add, in New York City, a passive house building is only in heating mode 4 months of the year, and the other 8 months of the year, there are a few shoulder months, but it's in cooling mode. And so but the cooling load is lower. And one of the key things is, as you were saying, Zach, in another way, is if we do enough of this, we won't stress the grid.
Yeah, Mark, I'm glad you bring that point up, because again, I'm always fascinated every time we have these events. And I mean, I love the project showcase events specifically because we keep talking about like these nuggets of information that kind of evolved over the last, 3 years that we've been doing this, and how you're getting more of the repeat stories of, if we do this, it affects this. And if we do that, then again, our cold climates in doing multifamily, well, we're not really in cold climates. We're in and having to deal with cooling these buildings because of the density and all these things. And so again, the flows of these conversations I just love. And again, Mark, great projects. And there was Wayne had a question, and then Zach, you had one. So I just want to make sure that I had Wayne in the right queue. Wayne, are you still with us? Unless I'm out of queue, and maybe I'll. Oh, sorry. Wayne just made a comment about an HVAC system. So Zach, we'll come back to you, because let's just talk about building of excellence.
Yeah, absolutely. So NYSERDA just announced the round 4 of Buildings of Excellence. And Mark, I know that you've been kind of intimately involved in Buildings of Excellence program now for some time. I was just wondering if you could share what impact that program has had on your practice.
Well, it gives a carrot to our clients, both money, which is important, but also a certain amount of prestige, and encouraging them when we propose. It used to be proposing an all-electric building was radical. Now almost everything we're doing is all electric. And having the carrot of winning the Buildings of Excellence helps us and encourages the clients to push the envelope. And then also getting some money is always good, because I haven't worked on a project in many years that doesn't get to a certain point where we've got to do some value engineering or other things to get it within budget, particularly in the last, I guess, 4 years now with all the inflation we've been seeing. But it's a great program, and it also it creates models to encourage other people to do it and find out about it. And one of the things to NYSERDA's credit in their programs is they want those of us who they give awards like this to, or the early design, to talk about what we found in places like this and share our knowledge, so that hopefully we can expand who knows enough about this to do it.
That makes sense. Thank you. And I know the program depends on practitioners like you to make it all happen. So thanks.
And the clients.
Yes, of course. And then again, you have that amazing team of clients and designers and all the consultants that just allow this to flourish and pull in different strategies. I mean, every building sometimes needs a different mechanical system or a different tweak here or there. And again, all this knowledge that is happening so rapidly. I mean, again, Mark, you and your firm have been leaders in all of this, and again, beautiful buildings, and all of them are still kind of evolving as you're trying to design and do better before it comes to the construction phase. So it's just again, appreciate you being a leader and finding and using the policy and all the tools to do your craft.
Thank you. And I also thank all the people I work with who make it possible, like Brian.
Excellent. And thanks for all those that completed the poll. It's great to get feedback and know where the market is and where all you are joining us from, and what part of the craft of building these amazing buildings you are involved in. So thanks for completing that. As I rushed into the office, in my little breakout room, we had Paul from Cambridge. And so one of our amazing sponsors is Adam White from Intelligent Memory. And so I'm sporting his football outfit, because I appreciate all the international flavor we had today, and wanted to make sure that Cambridge got a little bit more love, and also Adam and all the work that Intelligent Membranes is doing to support Passive House Accelerator, but also supporting all of you. So hopefully you will enjoy your August and maybe play a bit of football or soccer. And again, Americans, you can figure out which sport you want to play with in your summer months, and we will be back in September. So Bev, we've got 5 minutes. I'll let you say some parting words, and then we got a couple questions, and for those who want to stick around in the final 15, we will carry on with those questions. But Bev, over to you.
Well, thanks everybody for joining. I think hearing Mark's experience, and especially when he admits to not knowing everything. I love this. This is great. And like things that might have gone well or not gone as well. Like I love that about this community, is that we're all willing to share with each other and hopefully leapfrog over and make buildings better and better. Kudos, Mark, for the interest in low embodied carbon. It's sort of like the early days of energy efficiency. I feel like for very little cost, you can make huge impact. And so we need people like you being out there really pushing for those and then sharing what is working for people. So thank you, Mark.
You're welcome. Thank you.
All right, well, everyone, we're going to switch over to the final 15. So if you do need to depart and head back to work or back to whatever you were up to, we definitely appreciate you joining us every Wednesday morning or Wednesday afternoon or Wednesday evening, depending on where you are on this lovely planet that we all share and trying to save. So you saw the events, lots of amazing things happening with the accelerator. Again, amazing podcast. So yes, there's another one that's been put out this week, but I'm sure probably like myself that I'm a few weeks behind, and so again in August, enjoy sitting back and enjoying those podcasts. Enjoy all the great videos that are being pumped out in the YouTube with the reimagined buildings. I kind of wait now to Friday. It's again every day there's something great that Accelerator puts out. So I appreciate again to all the efforts with the Accelerator team, Zach and Kim and everyone else. And if you do need to head off, enjoy the rest of your day today. And next in the queue we had Andrea. So Andrea and sorry, let me get rid of that so I can do it. Sorry, let me just move up. So as Kim nicely posted, next was Andrea. And if Andrea, oh, there you are. Go ahead.
I think that her mic isn't working, but after her was Marina, I believe.
Yeah, Marina, why don't you go and then we'll come back. Marina, over to you.
No, it wasn't really a question. I was basically brainstorming. I tend to do that a lot. It's the perspective of we have a material that is high carbon, embodied, high embodied carbon. But what if the material is long lasting? Does it compensate? Usually it does. At least that's some of the conclusions we're getting here. Concrete, if you can make it to last 70 years and we can still reuse it somehow, and we're studying which solutions will work better for the different rubble, concrete rubble we're getting, it's a good bet. Because it is, at least for us here, it's a material with some advantages, more than metal. because of climate, mainly from my point of view. So it's a matter of balance. For instance, the solar panels, how long will they last? What we will do with the recycling? It's still being improved. We know we can still get more efficiency from them. Water heating, it's getting a good pass, but photovoltaic, for instance, I have the learning the info I've been getting is that photovoltaic panels are still having a long pass ahead to become really sustainable and efficient.
Yeah, great points, Marina. And I mean, when we're looking at the embodied carbon to concrete, when we're adding the flash, I mean, the stuff that I've learned is you can easily switch out, like in BC here, we can switch out from regular concrete to phase 1, and it doesn't affect the curing rate. But then as we add more fly ash, then the curing rate slows. And so now it's a balance of managing our construction schedules and say, do we want to have our lower embodied carbon by slowing down concrete from 28 days to 90 days? And then how does that affect, our schedule? So then it's a finance question too. And the fact that we're having these conversations and trying to figure out how do we, balance the construction schedule, the finance schedule, and the embodied carbon is great. And now we're pushing our big concrete companies to figure out some of these answers of, if we still want to build the concrete, how do we manage the construction schedule? So great dialogue. And again, the fact that we're asking questions and seeing results is all we can do, which is great. Netanya, you had a question. I'm just going to make sure that you are still here.
Hi, yeah, I'm still here.
Yeah, go for it. Please ask your question.
Hi, well, it was kind of just Marina just asked, I guess, kind of as well, just like, how long, and when we talk about, like cradle to cradle and everything, just like to what extent, I guess, are like solar panels, like worth it? I mean, in the sense that like once they don't work anymore, like have we thought about what to do with them? Is that like a future problem that like, we'll get like we'll figure out when we get there kind of thing? Or and like also I guess in terms of like the building, like is that considered when designing what like the afterlife of products in general, but specifically solar panels?
I think that just to jump in with one thought around that, and that is that solar panels definitely have environmental impact. I think that it's important for us to compare solar panels to the massively environmentally destructive energy system that we have now with the fossil fuels, and then to really focus on improving them, but do what we're doing in the building energy efficiency space, which is to do everything we can to reduce the overall energy load on the system. So I think that there's no question that there are environmental impacts from solar panels, but I think the context is critical.
Yeah. I think one thing too that to add to that is that now these systems are coming out which are dual use. It's not just a panel on a roof anymore. It's a cladding system. It's a railing system. Even in Ontario here, like the government is looking at switching a lot of their noise barriers to solar, because it's now possible to start doing these things. So yeah, granted, there is an issue, an end of life issue, but this is like you're getting, it's like you're going to be constructing these things anyway. So why not add in,
Yeah, I mean, I love it being in a hot climate, and again, I hate to say this, but when you park your car and to protect the car, you've got all the canopies are solar panels. So I mean, the intrigue and design that we're incorporating solar panels into our life is great. And again, we got to pick and choose our energy resources, and so being able to entwine them in design and making things work is a challenge for all of the design community, which is pretty exciting. And again, I mean, Zach, I always have to come back to you because the images you've imposed on us with solar punk, I mean, it's just so interesting to just see how we can intertwine great design in our beliefs of trying to improve things and be able to have creativity and fun art at the same time. So again, I'm always inspired by the solar punk movement and the great designs and things they think about, because once it's designed, then it's, comes back to those early days of Star Trek, Star Wars, and science fiction of like, how do we incorporate that into our daily lives? And I mean, we all have cell phones now. So, I mean, soon enough, we're going to have more of this interesting buildings that improve our livelihood. Dale, you got a hands up. What's going on over there in Tacoma?
Well, many things in Tacoma, but this has been raised before about solar panels. I was wondering if anybody had any more depth of knowledge than I, when mine is really outdated, but 25 years was one statement. And we also have American Solar Energy Society, International Solar Energy Society. You have the group that meets to sell solar panels. So this question should be able to be answered by many people. They started recycling more and more. I know many people are looking at recycling materials. So I would think we're up at least probably 90% of a solar panel being recycled after 25 years, and some even last longer. One of the problems they found is, well, they don't have the volume for recycling, but they last so long that people forget about them. They work. Mine still work in Hawaii. In fact, we recycled the hot water panels. Finally, they fell apart after 19 years. And that's one thing we did. I was in Oahu, where they have very little recycling. So, and that material was taken for recycling. So this question just needs to be looked in a little more depth with people who handle this daily. And there's different organizations who are on top of doing this.
Yeah, no, good point, Dale. I mean, again, as we're doing more of this work, more of that research will be able to come out and for us to figure out. And I mean, again, there's just creative ways of what those older panels can do. And again, if they're still working, unless you want to pay to upgrade them, I mean, if they're still getting good output for them, why replace them? So
what Wayne just said is true. They degrade, not really wear out. So
yeah,
you can fit them for different purposes. We're doing that with the batteries from our electric cars.
Yep.
And maybe the one for my Tesla right now, because that light just came on yesterday. And I found out Tesla has so much confusion. You don't see this very often, but it looks like the battery pack warranty runs out like next month.
Well, you go deal with that. And I think we've got all the questions wrapped up, everyone. If I missed you, raise your hand and we'll get you in there. But I think if not, we will send Mark and his amazing team off to get these buildings started, because I think, Mark, you said digging starts in September on one of them, and
yeah,
that's exciting.
Definitely, and thank you all.
No, Mark, I think all I'm seeing right now is again, more praise and more more thanks to, again, a great event, and we're having some more conversations of solar panels. So I'll let those chime into the chat, but I think all of us at Accelerated could let you go. Thanks again for amazing presentation. Again, congrats on being part of the Building of Excellence and being able to bring 2 buildings for the community that again, they're buildings that are supporting the neighborhood by taking care of local community and also dealing with transitioning people from different parts of life so they can be part of society, and again, and even supporting our elderly. So great buildings. And otherwise, Accelerator team, if you don't see anything else, Kim, I think you can hit the ejection button and we can carry on with our day.
All right. See everyone next week.